Hello, in this lecture we'll find out the area of a rectangle that is inside the triangle. In the drawing we have a triangle ABC. This is triangle ABC. Inside this triangle ABC we have this rectangle PQST, and our mission is to find out the area of this rectangle PQST. In addition, we know that side AB of this triangle ABC equals to 10 units in its length, side AC equals to 17 units in its length, and this is side BC that equals to 21 units, and our mission is to find out the area of this rectangle PQST. So in the first step we do a construction, that is to say from point A we go perpendicular on PQ. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point A and PQ. This point is point M. In the next step, we'll extend the perpendicular AM by straight line until it touches side BC or triangle ABC. And we will define the touching point of the extended perpendicular AM with side BC. This point is point N. By doing this construction, we can get those two angles. Those two angles, they are defined as corresponding angles, and they are located between the parallel lines PQ and BC. And according to the rule that corresponding angles between parallel lines are equal to each other, those two angles are equal to each other. But this angle equals to 90 degrees according to our construction, therefore this angle must be also equal to 90 degrees. Likewise, those two angles are also defined as corresponding angles, and they are located between the same two parallel lines PQ and BC, and therefore they are equal to each other. But this angle equals to 90 degrees according to our construction, therefore this angle must be also equal to 90 degrees in its size. In the next step, we define the length of this line segment BN as X. Actually, we define the length of line segment BS as X. This line segment BS equals to here we define the length of line segment BM as X. This is line segment BN is equals to x according to our definition. So what is the length of this line segment NC? Line segment NC, from drawings is very easy to see that line segment NC equals to BC minus BN. So line segment NC equals to BC minus BN. So NC equals to BC. BC is 21 according to what is given in the question, minus BN. BN is x according to our definition, therefore in total NC equals to 21 minus x. This is 97 NC, and this is equals to 21 minus x units in its length. In the next step, I'll copy the right angle ABN, and in your page we'll implement the Pythagoras theorem on this right angle, triangle ABN. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So here by PT is abbreviation for Pythagoras theorem. Side PN of the right angle ABN equals to x units in its length, and the hypotenuse AB equals to 10 units in its length according to what is given in the question. So actually, this is the right angle ABN, this is the common from the original drawing, according to the Pythagoras theorem. In this right angle ABN, AB square equals to AN square plus BN square. So I write it down. This is equation 1. AB square equals to AN square plus BN square. Here we subtract BN square from this equation, equation 1, and you get that AN square equals to AB square minus BN square. So according to equation 1, AN square equals to AB square. AB is 10, therefore AB square is 10 squared, that is 100, minus BN square. BN is x, therefore BN square is x squared. So according to equation 1, we actually found out that AN square equals to 100 minus x squared. In the next step, I'll copy this right triangle A and C, and then you print it. We will implement the Pythagoras theorem in this right triangle A and C. Here by PT is a version for Pythagoras theorem. Side NC of the right triangle is equals to 21 minus x units in length. And the hypotenuse AC equals to 17 units, according to what is given in the question. So actually, this is the right triangle A and C that are covered from the original drawing. According to the Pythagoras theorem, this right triangle A and C, AC square equals to AN square plus NC square. Here we subtract NC square from this equation 2, and we get that according to equation 2, AN square equals to AC square minus NC square. So AN square equals to AC square. AC is 17, therefore AC square is 17 square, that is 289 minus NC square. NC is 21 minus x, therefore NC square is 21 minus x square. So actually, according to equation 2, we found out that AN square equals to 289 minus 21 minus x squared. This is according to equation 2. But according to equation 1, we've already found out that AN square equals to 100 minus x squared. So we have two different equations for the value of AN squared. Therefore, we create equation 3 that states that AN square, according to equation 1, must be equal to AN square according to equation 2. So AN square according to equation 1 is 100 minus x squared. It must be equal to AN square according to equation 2. AN square according to equation 2 equals to 289 minus 21 minus x squared. So actually, the conclusion found out that according to equation 3, 100 minus x squared equals to 289 minus 21 minus x squared. So here we'll open the brackets of this expression 21 minus x squared, and we get that according to this equation 3, hundred minus x squared equals to 289 minus, and we have 21 minus x squared equals to 21 squared, that is 441, plus x squared minus 2 times 21 times x is minus 42x. So actually, according to equation 3, we found out that hundred minus x squared equals to 289 minus, inside the brackets we have 441 plus x squared minus 42x. According to equation 3, we found out that 100 minus x squared equals to 289, and we have minus before the brackets, so we'll open the brackets here, and after we open the brackets, this expression will be equal to minus 441 minus x squared And here minus 42 is plus 42, because minus times minus is plus. So according to equation 3, which we found out that 100 minus x squared equals to 289 minus 441 minus x squared. So here we have minus x squared on both sides of this equation 3, so minus x squared will get cancelled. What we cancel minus x squared. In this side of equation 1, we left only with 100. In the other side of the equation, this side of equation 3, we left only with 100. And the other side of this equation, equation 3, we left with 289 minus 441 plus 42x. Here we add 441 to this equation, equation 3. And we get that according to this equation 3, 100 plus 441 is 541. And it is equals to 289 plus 42x. So here we subtract 289 from this equation 3. And we get here that according to this equation 3, 541 minus 289 is 252 equals to 42x. Okay, so here we divide this equation 3 by 42. Finally we get that according to this equation 3, x equals to 252 minus 42 is 6, so x equals to 6 units in its length. We turn to equation 1. According to equation 1, we found out that an squared equals to 100 minus x squared. But we just right now found out that x is 6, therefore x squared is 6 squared, it is 36. So in total, according to equation 1, an squared equals to 100, and minus x squared is minus 36. So an squared equals to 100 minus 36, that is 64. So according to equation 1, we found out that an squared equals to 64. We will take out all of this equation 1, and finally get that an equals to the square root of 64, that is 8. So an equals to 8 units in its length. So actually, 9 segment an equals to 8 units in its length. So I write it down here. An equals to 8. We define the width of this octagon PQ as T, the width QS as B. And we define the length of this octagon PQ as T, that is to say, the length PQ is A. Okay, again we define the length of this octagon PQ as A and the width QS as B. We have already found out that AN equals to 8 units in its length. So what is the length of line segment AM? From the drawing it is very easy to see that AM equals to AN minus MN. Again, AN equals to AM equals to AN minus MN. So I write it down. AM equals to AN minus mn. So am equals to an, that is 8, minus mn. So before that, we know that all the angles inside a rectangle are right angles, so those two angles in rectangle PQST, each of them is equal to 90 degrees in its size. So this angle equals to 90 degrees, and this angle also equals to 90 degrees. So there are two angles in rectangle PQST. So in the next step, we'll focus on this small quadrilateral MQSN. Inside this small quadrilateral MQSN, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the size of this fourth missing angle, in total it must be equal to 360 degrees. According to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, this fourth missing angle must be equal to 90 degrees in its size. So inside the small quadrilateral MQSN, we have 4 right angles, and according to rule 6, any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So we relate to this small quadrilateral MQSN as a rectangle for the first 4 right angles. But we also know that the opposite sides of a rectangle are equal to each other. So in this small rectangle MQSN, side QS equals to the opposite side MN, but QS equals to B, therefore MN must be also equal to B. We have already found out that AM, this line segment AM equals to AN minus MN. So AM equals to AN, that is 8, minus MN, that is B. So in total, AM equals to 8 minus B. AM equals to 8 minus B. Those two angles are defined as corresponding angles, and they are located between the parallel lines PQ and BC, and therefore they are equal to each other. So if we define this angle as alpha, then this angle must also equal to alpha, according to the rule that I mentioned, that corresponding angles between parallel lines are equal to each other. Likewise, those two angles are also defined as corresponding angles, and they are located between the same two parallel lines PQ and BC, and therefore they are equal to each other, according to the same rule that corresponding angles between parallel lines are equal to each other. So if we define this angle as beta, then this angle must be also equal to beta, according to the rule that I mentioned. Okay. In the next step, we prove that the big triangle ABC is similar to this small triangle, triangle APQ. And again, we prove that the big triangle ABC is similar to this small triangle, triangle APQ. Okay, so write it down. So while the big triangle ABC is similar to the small triangle APQ. First of all, those two angles are both equal to alpha, therefore they are equal to each other. In addition, those two angles are both equal to beta, therefore they are equal to each other. And finally, this angle A, is a common angle that belongs to both angles, so I know that angle A equals to itself is a common angle that belongs to both triangles. So actually found out that all the triangles with the big triangle ABC are correspondingly equal to all the triangles in the small triangle APQ. Therefore, triangle ABC is similar to the small triangle APQ according to angle similarity rule. So I write it down. The big triangle ABC is similar. This is the sign of similar to the small triangle APQ. According to angle similarity rule. And whenever you have two similar triangles, then the ratio between their heights must be equal to the ratio between their sides. Repeat again, in two similar triangles, the ratio between their corresponding heights must be equal to the ratio of their corresponding sides. And therefore, because of the fact that the big triangle ABC is similar to the small triangle APQ, it means that the height AM in the small triangle APQ over the height AN in the big triangle ABC. So here AM over AN is the ratio between the corresponding heights of the two similar triangles ABC and APQ. So the ratio between their heights must be equal to the ratio between their sides, between their corresponding sides. That is to say, side PQ in the small triangle APQ must be equal to side BC in the big triangle ABC. Repeat again that equation 1, this is equation 1, it means that the ratio between the heights of the two similar triangles, that is to say AM over AN, must be equal to the ratio between their heights. Must be equal to the ratio between their sides, that is actually PQ over BC. Again, the ratio between the heights, that is AM over AN, must be equal to the ratio between their sides, that is PQ over BC. AM is 8 minus B over AN. AN is 8 and it is equals to PQ. PQ is 8 according to our definition. Over BC. BC equals to 21 according to what is given as the question. So according to equation 1, we found out that 8 minus B over 8 equals to A over 21. Here we cross multiply this equation 1. And again, this according to this equation 1, 8 times A equals to 21 times 8 minus B. Here we divide this equation 1 by 8, and we get that A equals to 21 over 8 times 8 minus B. So A equals to 21, we'll open the brackets in this side of equation 1, so 21 over 8 times 8 is 21. And here we have 21 over 8 times minus B is minus 21b over 8. So here we multiply this equation 1 by b. So you get it according to this equation 1, a times b equals to 21b. And here we have minus 21 over 8 times b is minus 21 over 8 times b squared. So according to equation 1, found out actually that a times b equals to 21b minus 21 over 8 times b squared. But what is a times b? A is the length of rectangle PQST and b is the width. And we know that the length times the width is the area of any rectangle, and especially it will be the area of rectangle PQST. So according to this equation 1, the area of rectangle PQST is actually a times b equals to 21b minus 21 over 8 times b squared. Or in other words, we have the area of rectangle PQST, that is a times b, of function of b. Okay, it is the area of rectangle PQST as function of b. B is the width of this rectangle PQST. B is the independent variable because we have to choose any width that we would like, and after we choose the value of B, we get immediately the area of rectangle PQST. Therefore, B is the independent variable and the area A times B is the dependent variable. And our mission is to find out the maximum area of this rectangle PQST. Or in other words, our mission is to find out the maximum value of A times B, because A times B is the area of rectangle PQST. Or in other words, we have to find out for which B is the width, for which B the dependent variable A times B, that is the area of rectangle PQST, will get its maximum value. Okay, so in order to find out what is the maximum value of A times B, that is the area of rectangle PQST, we have to differentiate this function area and equate is the relative to 0, and by differentiating this function area and equating is the relative to 0, we get extreme point of this function area. And in order to find out whether if the extreme point that we found it is minimum extreme point or maximum extreme point, we have to draw the function of this, the graph of this function area, and from the graph itself we will find out whether if the extreme point that we found it is a maximum extreme point or minimum extreme point. So in the first step, we will differentiate this function area and equate its derivative to 0. So here d is the abbreviation for derivative. So we take the derivative of the function area, that is actually 21b minus 21 over 8 times b squared. And we will differentiate this function area according to the variable b. So it is db. Again, db, the derivative means that we take the derivative of this function area according to the variable, the independent variable b. And then we equate this derivative to 0 in order to find out the extreme point of this function area of rectangle PQST. So first of all, we have to find out the derivative of this function area. So what is the derivative of 21b? Actually, the derivative of b is 1, therefore the derivative of 21b will be equal to 21 times 1, that is 21. And what is the derivative of this expression minus 21 over 8 times b squared? Actually, the derivative of b squared is 2b. Therefore, in total, the derivative of this expression will be equal to minus 21 over 8 times 2b, and it is equals to 0. So we shall find out that according to equation 1, 21 minus 21 over 8 equals 21 minus 21 over 8 times 2b equals to 0. This expression is the derivative of the function area of rectangle PQST, and we equated the derivative to 0 in order to find out extreme point of the function area of rectangle PQST. Now we'll solve this equation in order to find out the extreme point of rectangle PQST. Is the extreme point of the function area, that is the extreme point of rectangle PQST. Okay, so here we take 21 as a common factor out of those two expressions. So what is left from 21 after we took away 21 as a common factor? What is left is actually 1, and what is left from this expression minus 21 over 8 times 2b after we took away 21 as a common factor? What is left is actually minus 2b over 8 equals to 0. So here we divide this equation 1 by 21, and you get that 21 over 21 is 1, so in this side of the equation we left only with 1 minus 2b over 8, and the other side of this equation 1 we have 0 over 21 is 0. So according to equation 1 we shall find out that 1 minus 2b over 8 equals to 0. Here we add 2b over 8 to this equation 1, and we get that 1 equals to 2b over 8. So here we divide both the numerator and the denominator of this expression by 2, and we get that according to equation 1 equals to 2b over 2 is b, and 8 over 2 is 4. So we found out that 1 equals to b over 4. Here we multiply this equation 1 by 4, and finally we get that b equals to 4 units in its length. So we found out that the extreme point of this function area of rectangle PQST is b equals to 4. So in the next step, I will draw the graph of this function area of rectangle PQST in order to find out whether the extreme point that we found is a minimum extreme point or a maximum extreme point. Actually, I already drew the function area of rectangle PQST. This is the function area of rectangle PQST. In the y-axis, we have the area that is a times b. Again, a times b is the area of rectangle PQST. So in the y-axis, we have the area, and in the x-axis, we have the width b. Okay, and from the graph, you can see, it's very easy to see that when the width b equals to 4, here b equals to 4, then the area of rectangle PQST is a times b equals to, it is a little bit greater than 40. This number is 40, so it is a little bit greater than 40. So, therefore, according to the graph, found out that the extreme point b equals to 4 is the maximum extreme point. Okay, so the only thing that is left to do is to put the extreme point, the maximum extreme point b equals to 4 in the area function in order to find out what is the maximum area of rectangle PQST. And then again, the function area of rectangle PQST is a times b. This equals to 21b minus 21 over 8 times b squared. Now we substitute b by 4 in order to find out what is b is the maximum extreme point. So what is the maximum area of rectangle PQST? We do it now, we get that a times b, that is the area of rectangle PQST. In this way, in this case, it is the maximum area because b is the extreme point of the rectangle. So the maximum area a times b equals to 21b. b is 4, so it is 21 times 4 minus 21 over 8 times b squared. b is 4, therefore b squared is 4 squared, that is 16. So the maximum area of rectangle PQST equals to 21 times 4 is 84. And here, this expression we have 16 over 8 is 2, so in total this expression will be equal to 2 minus 21, that is minus 42. So if we found out that the maximum area of the rectangle PQST equals to 84 minus 42, that is 42. So we found out actually that the maximum area of rectangle PQST is equals to 42 square units. Okay, again, if we found out that the maximum area of this rectangle PQST that is located inside this triangle ABC is equals to 42 square units. And when the area of rectangle PQST is equals to 42 square units, then the width B is 4, So what is the length? We'll find out the value of the length when b equals to 4 and the area gets its maximum value, that is 42 square units, according to equation 1 that states that a equals to 21 minus 21 over 8 times b. We just have to substitute b by 4 in order to find out what is the length of the PQST when it gets its maximum area, that is 42 square units, and the width is b. So we get that the length A equals to 21 minus 21 over 8, and b is 4. So it is 21, and here we divide both the numerator and the denominator of this expression by 4. 4 over 4 is 4, so in the numerator we left only with minus 21, and in the denominator we have 8, so 8 over 4 is 2. So the length of Arcturian PQST when its area is maximum, it is 42 square units, the length equals to 21, and minus 21 over 2 is minus 10.5, and 21 minus 10.5 is 10.5. So we found out that when the width b equals to 4 and the length a is 10.5, then the area is a times b. That's actually a is 10.5 times b, that is 4, and 10.5 times 4 is 42 square units. Repeat again. Actually found out that when the width of this arterial PQST is 4 units and the length is 10.5 units, then the area of arterial PQST equals to 42 square units. That's actually the maximum area of this arterial PQST. Okay, so in the next step I'll summarize the lecture. In this lecture, we found out the maximum area of this rectangle PQST. So in the domain we have triangle ABC. Inside this triangle ABC we have this rectangle PQST, and our mission is to find out the maximum area of this rectangle PQST. In addition, we know that side AB of triangle ABC equals to 10 units in itself, side AC equals to 17 units in itself, and this is side BC of triangle ABC, this equals to 21 units in its length. Repeat again, our mission is to find out the maximum area of this rectangle PQST. So in the first step we did the construction, that is to say from point A we draw perpendicular on PQ. So this angle equals to 90 degrees and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point A and PQ, this point is M. In the next step we extended the perpendicular AM until it touches side BC of the triangle, and we find the touching point of the extended perpendicular AM with side BC, this point SN. By doing this construction, we can deduce those two angles. Those two angles are defined as corresponding angles, and they are located between the parallel lines PQ and BC, and according to the rule that corresponding angles between parallel lines are equal to each other, those two angles must be equal to each other. But this angle equals to 90 degrees according to our construction, therefore this angle must be also equal to 90 degrees. Likewise, we have those two angles They are also defined as corresponding angles and they are located between the same two parallel lines PQ and BC, therefore they must be equal to each other. But this angle must equals to 90 degrees according to our construction, therefore this angle must be also equal to 90 degrees. In the next step, we defined the length of this line 7BN as x. So what is the length of NC? From the drawing it is very easy to see that NC equals to BC minus BN. Again, NC equals to BC minus BN. So NC equals to BC, that is 21 according to what is given in the question, minus BN, that is x according to our definition. So in total, NC, this line 7 NC equals to 21 minus x. In the next step, I copied the right triangle ABN in a new page and implemented the Pythagoras theorem in this right triangle ABN. So this is the right triangle ABN that I copied from the original drawing. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in this right triangle ABN is AB, therefore the square of the hypotenuse is AB square, and it must be equal to AN square plus BN square. Here we subtracted BN square from this equation in equation 1, and finally found out that AN square equals to AB square plus BN square. So AN is the missing side, so we leave it as it is. So AN square equals to AB square. AB is 10, therefore AB square is 10 squared, that is 100, minus BN square. BN is x, therefore BN square is x square. So in conclusion, I found out that according to equation 1, AN square equals to 100 minus x square. In the next step, I copied this right triangle ANC in a new page and we implemented the Pythagoras theorem and this right triangle ANC. This is right triangle ANC that I copied from the original drawing. According to the Pythagoras theorem, this right triangle ANC, AC square equals to AN square plus NC square. Again, AC square equals to AN square plus NC square. We subtracted NC square from this equation and found out that according to this equation 2, AN square equals to AC square minus NC square. So AN square, AN is the missing side, so we leave it as it is. Therefore, AN square equals to AC square. AC is 17 according to what is given in the equation. Therefore, AC square is 17 squared, that is 289 minus NC square. NC is 21 minus x, therefore NC square is 21 minus x square. So according to this equation 2, we shall find out that AN square equals to 289 minus 21 minus x square. This is according to equation 2. According to equation 1, we have already found out that AN square equals to 100 minus x square. So we have two different equations for the value of AN square. Therefore, we created equation 3 that states that AN square according to equation 1 must be equal to AN square according to equation 2. AN square according to equation 1 is 100 minus x square, and it must be equal to AN square according to equation 2. AN square according to equation 2 is 289 minus 21 minus x square. Okay, 289 minus 21 minus x square. So according to equation 3, we actually found out that 100 minus x square equals to 289 minus 21 minus x square. Here we open the brackets of this expression. And so I found out that according to equation 3, minus x square equals to 289 minus, and 21 minus x square equals to 21 squared, that is 441, plus x square, minus 2 times 21 times x is minus 42x. Then we open the brackets of this expression and found out actually that according to equation 3, 100 minus x square equals to 289. After we open the brackets, here this expression will be equal to minus 441 minus x square, and here we have minus times minus is plus, so minus 42x is plus 42x. So here we have minus x square on both sides of this equation 3, therefore minus x square will be cancelled. After we cancel minus x square, on this side of equation 3 we left only 100, and the other side of equation 3 we have 281 minus 441 minus 441 plus 42x. Here we added 141 to this equation, equation 3. If I found out that according to this equation, equation 3, 104 plus 441 is 541, and it is equal to 289 plus 42x. Here we subtract 289 from this equation, equation 3. If I found out that 541 minus 289 is 252. So 252 equals to 42x. Here we divided this equation 3 by 42 and found out that according to equation 3, x equals to 252 over 42 is 6. So x equals to 6 units in its length. Then return to equation 1. According to equation 1, we found out that an squared equals to 100 minus x squared. So an squared equals to 100 and x is 6, therefore x squared is 36. Therefore, 1 x squared is 136. So an squared equals to 100 minus 36, that is 64. So an squared equals to 64. We took out all those equation, and finally found out that an equals to the square root of 64, that is 8. So here, this is actually line segment AN, that is equals to 8 units in its length. We know that PQST is rectangle, and therefore those two angles, they are both right angles because there are 2 out of the 4 angles inside rectangle PQST, therefore they must be equal to 90 degrees in their sizes. In the lecture, we focused on this small quadrangle MQSN. Inside this small quadrangle MQSN, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees, so 270 degrees plus the size of this fourth angle. In total, they must be equal to 360 degrees according to the rule that the sum of the angles in any quadrangle is equal to 360 degrees. Therefore, this fourth missing angle must be equal to 90 degrees in its size. So in total, inside quadrangle MQSN, we have 4 right angles. And according to rule 6, any quadrangle that has 4 right angles must be this rectangle not a square. So we relate to this small quadrangle MQSN as a rectangle because it has 4 right angles. But we also know that the opposite sides of a rectangle are equal to each other. So in the small rectangle MQSN, side QS must be equal to the opposite side MN. But QS, we actually defined the width of this rectangle as B and the length PQ as A. Therefore, the width QS is B and QS in rectangle MQSN, QS equals to MN. According to the rule that the opposite sides of rectangle are equal to each other. But QS is B according to our definition, therefore MN must be also equal to B. Okay, so what is the length of this line segment AM? Line segment AM equals to AN minus MN. Again, AM equals to AN minus MN. AN equals to AN minus MM. So AM equals to AN, that is 8, minus NM, that is B. So in total, AM equals to 8 minus B. Those two angles, they are defined as corresponding angles and are located between the two parallel lines PQ and BC, and therefore they are equal to each other. According to the rule, that corresponding angles between parallel lines are equal to each other. So if this angle is alpha, then this angle must be also equal to alpha, because they are equal to each other. Likewise, those two angles are also defined as corresponding angles. Again, those two angles are also defined as corresponding angles, and they are located between the same two parallel lines, PQ and BC, and therefore they are equal to each other. So if this angle is beta, then this angle must be also equal to beta. In the next step, we proved that the big triangle ABC is similar to this small triangle APQ. Why ABC is similar to triangle ABC is similar to triangle APQ? First of all, those two angles are both equal to alpha, therefore they are equal to each other. In addition, those two angles are both equal to beta, therefore they are equal to each other. And finally, this is angle A, that is a common angle that belongs to both triangles. So I down that angle A equals to itself is a common angle that belongs to both triangles. So I actually found out that all the angles in the big triangle ABC are correspondingly equal to all the three angles in the small triangle APQ, and therefore those two triangles are similar to each other according to angle similarity rule. Repeat again. The big triangle ABC is similar, this is the sign of similar to the small triangle APQ according to angle similarity rule. And whenever you have two similar triangles, then the ratio between their heights must be equal to the ratio between their sides. And therefore, here it means that the height AM in the small triangle APQ over the height AN in the big triangle ABC, AM over AN is the ratio between the heights of the two similar triangles, must be equal to PQ in the small triangle APQ over BC in the big triangle ABC. So the ratio between the heights, that is AM over AN, must be equal to the ratio between their sides, that is PQ over BC. Okay, AM is 8 minus B and AN is 8. Repeat again, AM is 8 minus B and AN is 8, and it is equal to PQ. PQ is A, according to our definition, it is the length of rectangle PQST, that is A, so we substitute PQ by A, and BC equals to 21 units according to what is given in the equation. So according to equation 1, we actually found out that 8 minus B over 8 equals to A over 21. Here we can multiply this equation with equation 1, and finally found out that 8A equals to 21 times 8 minus B. Here we divided this equation 1 by 8, and finally found out that A equals to 21 over 8 times 8 minus B. So here we open the brackets on this side of this equation 1, and finally found out that A equals to 21 times 8 over 8 is 21, and 21 times 8 minus B is minus 21B over 8. So here we multiply this equation 1 by B, and finally found out that A times B equals to 21B minus 21 over 8 times B squared. What is A times B? A is the length of this rectangle PQST, and B is the width. Therefore, the width times the length is the area of this rectangle PQST. So according to equation 1, the area of rectangle PQST, that is A times B, equals to 21B minus 21 over 8 times B squared. So actually we have the area of rectangle PQST, that is A times B, as function of B. B is the width, and it is the independent variable, and the area A times B is the dependent variable, because we have the right to choose any width that we want, that we would like, and by choosing the width, we immediately determine the area A times B. So A times B, that is the area of the rectangle PQST, is the dependent variable, and B is the independent variable. And our mission is to find out the maximum area of this rectangle PQST. Or in other words, our mission is to find out the maximum value of the dependent variable A times B, because A times B is the area, and our mission is to find out the maximum area. So our mission is to find out the maximum value of A times B, or for which B the value of A times B will get its maximum value. In order to find out what is the maximum value of A times B, that is the area of rectangle PQST, we will differentiate this function area, and we will equate its derivative to 0. By differentiating this function area and equating its derivative to 0, we will find out the maximum, the extreme point of this function area, and then in order to determine whether if the extreme point that we found is minimum extreme point or maximum extreme point, we will draw the graph of the function area, and from the graph itself we can easily find out if the extreme point that we found is minimum extreme point or maximum extreme point. Of course, we're interested in the maximum extreme point of this function area, because the maximum extreme point will be also the maximum area of this rectangle PQST. Why? Because A times B is the area of rectangle PQST. So in the first step, we differentiate this function area, and we differentiate it according to the independent variable that is B. Therefore, it is over dB, and we equated the derivative to 0 in order to find out the extreme point of this function area. So what is the derivative of 21b? Actually, the derivative of b is 1, therefore in total the derivative of 21b is 21 times 1, that is 21. Here the derivative of 21b is 21, and the derivative of this expression minus 21 over 8 times b squared. We know that the derivative of b squared is 2b, and therefore in total the derivative of this expression will be equal to minus 21 over 8 times 2b. Okay. The derivative of minus 21 over 8 times b squared equals to minus 21 over 8 times 2b. And we must equate the derivative to 0 in order to find the extreme points in the function area. So we equated this derivative to 0. Then we took 21 as a common factor out of those two expressions. So what is left from 21 after we took only 21 as a common factor? What is left is actually 1. And what is left from this expression minus 21 over 8 times 2b after we took only 21 as a common factor? What is left is actually minus 2b over 8, and it's equals to 0. Here we divided the equation 1 by 21, so 21 over 21 is 1, so in this side of the equation we left with only 1 minus 2b over 8. In the other side of the equation we have 0 over 21 is 0. So in conclusion, according to equation 1, we found out actually that 1 minus 2b over 8 equals to 0. Here we added 2b over 8 to this equation 1, and we found out that according to this equation 1 equals to 2b over 8. Here we divided both the numerator and the denominator of this expression by 2. So 1 equals to 2b over 2 is b, and 8 over 2 is 4. So according to equation 1 equals to b over 4. Here we multiply this equation 1 by 4, and finally found out that b equals to 4. So b equals to 4 is the extreme point of this function area. Now we have to draw the graph of this function area of rectangle PQST in order to find out whether if the extreme point that we found is a minimum extreme point or a maximum extreme point. Actually, this is the graph of the function area of rectangle PQST. In the y-axis we have the area, and the x-axis we have the width b. From the graph it is very easy to see that when the width b equals to 4, then the area gets its maximum value. This is a little bit greater than 40 square units. So in this way we actually verified that b equals to 4 is the maximum extreme point and not minimum extreme point. So the only thing that is left to do is to put the value of b equals to 4 inside the function area in order to find out what is the maximum area of rectangle PQST. Okay, again, this is the function area of rectangle PQST. A times b is the area, and the area equals to 21b squared minus 21 over 8 times b squared. Now we have to substitute b by 4 in order to find out what is the maximum area of rectangle PQST. We did it and found out that a times b, the maximum area, equals to 21b. b is 4, so it is 21 times 4 minus 21 over 8 times b squared. b is 4, therefore b squared is 4 squared, that is 16. So if we found out that the maximum area of a rectangle PQST is 21 times 4, that is 84, and here we have this expression 16 over 2 is 2, so in total this expression equals to 2 minus 21, that is minus 42. So the maximum area of rectangle PQST is 84 minus 42, that is 42. Repeat again. The maximum area of this rectangle PQST is equals to 42 square units. And when the maximum area equals to 42 square units, then the width is B. So what is the length? We get the length according to equation 1 that states that A equals to 21 minus 21 over 8 times B. We just have to substitute B by 4. We did it and found out actually that the length A equals to 21 minus 21 over 8 times B is 4. So it is 21, and we have this minus this expression. We divided both the numerator and the denominator of this expression by 4. 4 over 4 is 1, so in the numerator we left only with minus 21. In the denominator we have 8, so 8 over 4 is 2. So in total the length equals to 21 minus 10.5, because 21 over 2 is 10.5, and 21 minus 10.5 is 10.5. So if we found out that when the maximum area of rectangle PQST is 42, then the width B is 4 and the length A is 10.5, and the width times the length is A times B. A is 10.5, B is 4, so 10.5 times 4 is 42 square units. Repeat again. Found actually that the maximum area of this rectangle PQST is 42 square units. Okay, thank you very much.